Okay, 3.3 homework, exponent laws involving rational exponents. So number 1 asks us to evaluate the following using no decimals. So what's the cube root of 64? That's 4. The fourth root of 625 is 5. And the cube root of negative 8 over 125 can be thought of the cube root of negative 8, which is negative 2, over the cube root of 125, which is 5. Okay, so for number 2, we're going to first write in radical form, and then we're going to evaluate. Okay, so A is 125 square rooted, which is 5. Oh, sorry, cube rooted, which is 5. B is 16 to the exponent 3, fourth rooted. Okay, and you can do this either way in your calculator, 16 to the 3. And I get 8. Okay, negative 32 to the 1/5. So the fifth root of 5. Okay, I get negative 2. D. So in D we have a negative exponent. So what we actually have to do is we have to flip the fraction, like flip the number. So we get 1 over 16 to the 1/4. So we can write this, like the quarter root of 1 just stays as it is, so we can just leave that. So we're going to have to quarter root 16, which is 1 over 2. Okay, same for E. We have negative 27, so let's go 1 over negative 27. We'll just leave the negative with the 27 because, oh, it's cube. Because when we cube root of 1, we just leave it. So let's just deal with that negative on the bottom. Okay, so when we cube root negative 27, we actually get, or we can bring it out here, we get 1 over 3. So negative 1 over 3. Okay, we get 4 to the 7 square rooted. So 4 to the 7 is a big number, 16,384. But when you square root it, you get 128. Okay, on to G. So we're here. Okay, so negative 64 to the exponent 2, and then we're going to cube root it. Okay, so negative 64 squared, we get 4096. So it's kind of like doing like the cube root of 4096. And I get 16. Okay, for H we get 4 over 9 to the 1/2. So what we're actually doing is we're rooting 4 and we're rooting 9. So we get 2 over 3. Okay, I, 1 over 25. And this is to the negative 1/2. So let's actually flip that right away. We're going to have 25 to the 1/2, which is root 25. And I just get 5. Okay, we get 100 over 9 to the 3 over 2. So we're going to cube each of these, and then we're going to square root it. Okay, 100 to the 3, and then rooted is 1,000. 9 to the 3, and then rooted is 27. Okay, 64 over 27. Actually, this is a negative exponent, so I'm going to flip this. We're going to go 27 over 64. And we're going to raise this to the 2 over 3. Raise that to the 2, and then cube root. And if we individually do those, we have 27 squared cube root. I get 9. And then 64 squared cube root, I get 16. Okay, last one, 16 to the negative 1/2. So it's 1 over root 16 minus 8 to the negative 1/3, 1 over cube root of 8. So we actually have 1 over 4 minus 1/2, which is negative 0.25, or negative 1/4. Okay, number 3, simplify, leave your answers with exponents. So when we divide two numbers that have the same base, what we actually do to the exponents is we subtract them. So we would have 5 over 4 minus negative 3 over 4. And I'm going to say really pay attention to this double negative. So I get 8 over 4, which is k squared. Okay, B. Okay, so we have x to the 12, and that's to the 1/2. And then that's to the 1/2. So what we're essentially doing is multiplying all these numbers. So 12 to the 1/2 is just 6, and then that's raised to the 1/2, which is just 3. Okay, so I'm going to change these actually to exponents. I find them easier to deal with than radicals. So I get x to the 8 over 2 plus, so this would be x to the 10 over 5 raised to the 2. Okay, so this is just x to the 4, and then x to the 10 over 5 would be x squared, and then squared again would be x to the 4. So we have 2x to the 4. Okay, so for this one, we have 1/4 of 81. So I find it easier to put radicals on numbers, and then like a to the 8, I'm going to do to the 1/4, and then b to the 4, also to the 1/4. Okay, so the 4th root of 81 is just 3, and this will be 8 times 1/4, which is a to the 2, and then this is going to be b to the 1. Okay, so we have here x to the 3 over 2 times x to the 1 over 3. So when we do this, we add these exponents. Okay, but we need a common denominator here, so the common denominator will be 6. So we have 3 over 6, and then 9 over 6. Yep, just checking. 9, 10, 11, 12. We have 12 over 6, which simplifies to x squared. Okay, so we're on to F. And that's to the 1/2. Okay, so we have bracket A3, B to the 5 to the 1/4, because that's like the root sign, and then that's to the 1/2. So let's do again, A3, B5, and then that's going to be to the 1/8. So it's going to be a to the 3 to the 1/8, b to the 5 to the 1/8, which we can just write as a to the 3 over 8, b to the 5 over 8. Okay, for G, we're going to multiply 2 by just 1, so that's just 2. A to the 1/2 times a to the 2/3. We're going to add those exponents. Half. And then we have 9 to the a. Sorry, we're going to put the 9 here. When we have a to a negative exponent, what we can actually I'm going to leave that one. I'll use it with division. Okay, so 1/2 plus 2/3 is 7 over 6. So we have 2a to the 7 over 6 over 9a to the negative 5 over 3. So when we divide two numbers with the same base, we subtract the exponents. So we get 2 over 9 still. we get a to the 7 over 6 minus negative 5 over 3. So I get 17 over 6. Okay, so I get 2 over 9, a to the 17 over 6. So kind of a long one. I guess I could have done all those 3 a's together, but I broke them up, so, and that's okay too. Okay, last one, h. We're going to go cube root of 27, which I like when it's written as a radical, and then x squared to the 1/3, we're going to multiply that, x to the 2/3. Okay, and this is going to be multiplied by the quarter root of 16. And then we're going to multiply these two, so negative 1/2, x to the negative 1/2. So I get 3 times 2, so this is 3, this is 2, and we get x to the 2/3 plus negative 1/2. Okay, so I get 6, 2 over 3 minus 1/2. I get 1 over 6. So I get 6x to the 1 over 6. Okay, number 4a. What we're going to do is we're going to expand this into the bracket. You know what? Let me move D and E. Okay, so for 4a, 4 times 7 is 20. 7 7 is 14, so we get 28. Okay, and then we're going to add 2/3 and 6. And I'm just using the fraction button on my calculator, so I get 20 over 3. Okay, 28x to the 20 over 3. Then 4 times 3 is 12x, and I'm going to add 2/3 plus 4 over 3, and I get 2. And that's it. Okay, we can't add those two together because they're not like terms. Okay, so here's what's a little bit different. Our base here is 9. So when we multiply 9 to the 2/3 times 9 to the negative 1 over 6, what we're doing is we're keeping 9 as the base, and we're just adding the exponents. So essentially we would add 2/3 plus negative 1/6 minus, we'll keep 9 as the base, 2/3 plus negative 7 over 6. So we get 9 to the 1/2 minus, and then it's 2/3 minus 7 over 6. I get negative 1/2. Okay, so this is just root 9, which is 3. And this is 1 over root 9, which is 1 over 3. So 3 minus 1 over 3 is 8 over 3. Okay, we're going to do the same thing to C. Okay, we have the 5s as a base and the 2s as a base. So root 5 to the 1/2 times 5 to the 1/2, we would add those and we would just get 5. Okay, 5 to the 1/2 minus 2 to the 1/2, we would just write it out like that. Those are just two numbers, okay? And then these are conjugates, so when we actually multiply this, we get plus 5 to the 1/2, 2 to the 1/2, where those two cancel, and then minus 2, because it's 2 to the 1/2 times 2 to the 1/2, so we just get 2. So 5 minus 2 is 3. Okay, we're going to do the same thing to D and E. So in D, I personally like to change this to m to the 1/4 minus m to the 1/3. Okay, m to the 1/4 plus m to the 1/3. Again, these are conjugates, so that middle term is going to cancel out. Okay, so now let's FOIL. A quarter plus a quarter, we're going to get m to the 1/2. And then we're going to get plus m to the 1/4. Oh, we can actually multiply that, that's fine. M to the quarter times M to the 1/3. So what's a quarter plus a third? 7/12. Okay, so we get plus M to the 7/12, but then we're going to get minus M to the 7/12. And minus M to the a third plus a third is 2/3. These two middle numbers cancel out, and we get M to the 1/2 minus M to the 2/3. Okay, and last one, E. We're going to FOIL this. Okay, so there's a coefficient here, which is like the 4, the 9, the 3, and the 2. The common base is x in this case. So let's go 4 times 3 is just 12. And then x to the 4/3 times x to the 5/3. Let's just add those. Okay, so we have x to the 9/3. Okay, the next one. 4 times -2 is -8. 4/3 plus 2/3. 4, 5, 6, I get 6/3. Okay, 9 times 3 is 27. 1/3 plus 5/3 is 6/3. And then 9 times -2 is -18. And then I get 3/3. Okay, so all of these, I'm going to actually simplify the exponents. So we have 12x to the 3 minus 8x to the 2 plus 27x to the 2 minus 18x. Collect these like terms, 12x cubed minus, or it's going to be plus 19 x squared minus 18x. Okay, number 5. So in the numerator, we have a base of h and k, and then h and k in the denominator as well. So let's simplify these exponents on the h and on the k. Okay, we'll do both of them, and then we'll divide after. Okay, so same rule. Simplify the numerator, then simplify the denominator, then divide. So we get h to the a over 8. And then we get k to the -2a over 3 over h to the -a over 6, and then k to the -2a over 3. Okay, so let's just go ahead and divide them. So we're going to get a over 8 minus -a over 6. Okay, so in other words, I'm going to go in my calculator and do 1 over 8 plus 1 over 6, I get 7 over 24. So this is actually h to the exponent -7a over 24. Okay, for this k, I'm going to go -2a over 3 minus -2a over 3. And I think that just cancels out. So that's our answer. Okay, last one, B. Again, we have the coefficients. These are added though, and then it's divided. Okay, so I can see how this is divided. Well, let's multiply by the reciprocal. So we have 3x to the n plus 7x to n over 3 plus 7x to the n times 1 over, instead of writing it like that, let's write it as x to the 2n over 2. These 2's cancel out, it's just x to the n. So in my head, I'm like, in the numerator, can I factor out an x to the n? So I get 3 plus 7 x to the n, because if we were to expand this, we'd get 7x, and then we'd add the exponents, so 2n. So that's good, over 3 plus 7x to the n, and then that's times 1 over x to the n. So those cancel, I get 1.